Hello, this is week 9 and 10. Today I will explain the haptic feedback glove prototype I built. The goal of this project is to simulate the feeling of touching virtual objects by stopping a person's finger from moving when it reaches a certain point. The design uses an ESP32 microcontroller, 3D printed parts, a potentiometer, and an SG90 servo motor. How the glove senses finger bending. Each finger pulls a string when it bends. That string is connected to a potentiometer. As a person closes their finger, the string rotates the potentiometer's shaft. The ESP32 reads this rotation as an analog value from 0 to 4095. When the value is around 4000, the finger is fully open. As a person bends their finger, the value decreases, so the glove can constantly measure how much the finger is bent. Inside the potentiometer, there is a spring-based return mechanism, so when the finger relaxes, the potentiometer rotates back to its starting position. This resets the string tension automatically. How the glove creates haptic feedback. To simulate touching an object, I use an SG90 servo motor. The servo can rotate an arm or block inside the 3D printed housing. When the servo moves to a certain angle, it locks the string, stopping the finger from bending any further. This makes the user feel like their finger hits a solid object, even though it's only the mechanism stopping the string. In my demonstration, I show just the middle finger working. The ESP32 prints the middle finger bend value. I command the servo to rotate to a specific angle, and the servo blocks the string to create a resistance, creating haptic feedback. How the components are wired. Both the potentiometer and the servo use 3 pins, but they do different things. Potentiometer pins have a ground pin, a volt pin, and signal viper, and servo motor pins have brown-black pins, which responds to ground pins, and red, which responds to volt pins, and they are connected to 5V power in ESP, and orange-yellow that responds for capable digital pin.